Hey guys, welcome back to OIC Chris, where it's never too late to have an OIC moment. I just want to say thank you to everyone who joined the live stream last week Friday, the 8th of May. I really enjoyed it. It was a big learning curve. During the live stream I had a request for chemistry videos, so I'm going to be starting with the May-June past papers for chemistry for 2021. So this video will be covering the rates of reaction questions. But before we get into that, I just want to say if you guys are enjoying the videos and they are helping, please consider subscribing to the channel. Leave your comments and questions down in the comment section below and I'll get back to them. And thank you for watching the video. So let's jump into it. Okay, let's have a look at question 5. So question 5 is looking at the rates of reaction. So it says 2 experiments, 1 and 2, are conducted to investigate one of the factors that affect the rates of reaction for aluminum carbonate with excess hydrochloric acid. Hydrochloric acid, or the balanced equation, is given below, and then they give us a picture of the apparatus. Okay, so note that just in the picture of the apparatus we have hydrochloric acid, which we can control with a stopper. You can see that we have a syringe, which means we're capturing gas of some sort. Okay, so that will have some form of measurement. And then we have our Al2CO3 at the bottom of the beaker. Okay, and then they give us experiment 1 and experiment 2, some details over there. So 5.1 says define the rate of reaction. Okay, so that's just the definition that you guys need to learn, so I'm not going to be spending time on that. 5.2 says use the experiment set up above to measure state the measurement, sorry, that must be made to determine the rate of the reaction. Okay, so if we look at what rate of reaction talks about, okay, it's the change in something over the change in time. Okay, so time's always going to be a measuring factor. So the first one you can write down is time. Okay, because the rate of something changing always deals with a change in time. And then this can be volume, it can be moles, it can be whatever you want to measure. But you can see that in this reaction they've given us concentration, they've given us moles, so yeah, you can write any one of the following. We can use the volume of the gas even, so volume of gas, and that will be CO2 gas. Okay, or we can use the amount, how long it takes for Al2 CO3 to be used up. Okay, now if we have a look at 5.3 says use the collision theory to explain how the average rate or reaction rate in experiment 1 differs from the average reaction rate in experiment 2. Okay, so we can see in experiment 1 they've stated there we have 100 centimeters cubed and 1.5 moles per decimeter. In experiment 2 we have 50 centimeters cubed and 200 moles per decimeter of HCl. Okay, so just a quick recap over here. Collision theory pretty much states that the reaction rate is proportional to effective collisions. Okay, so we need effective collisions to have a higher reaction rate. So the key point here, as I say, pick experiment 1 or 2 and talk about it. Okay, so I'm going to pick experiment 2 for this one. So we're going to be looking at 2. Okay, and the first thing that we can note is we have a smaller volume but a higher concentration. Therefore, we have more particles per volume, or per unit volume. Volume of HCl. Okay, the next thing that we can see over there, because there's more particles per unit volume, we're going to have more effective collisions within our container, and because of that we shall have a higher reaction rate. Okay, so you don't always have to state the collision theory if we're using it, you just need to understand how to use it. Okay, now looking at 5.4, it says the average rate of reaction for experiment 2 during the first 2.5 minutes is 4.4 times 10 to the negative 3 moles per minute. Okay, so they've given us the time, 2 minutes, they've given us the rate of the reaction, and we want to know what the change in moles is, because it then says calculate the number of moles of Al2CO3. Okay, So remember we said over here the rate of reaction is just the change in something over change in time, so we can write this as the rate of reaction equals to the change in moles all over the change in time, which means we have 4.4 times 10 to the negative 3 is going to then equal to delta n over the change in time is 2.5 minutes. Okay, so if you multiply this that side, delta n is then going to give you, let's have a look here, delta n is 0.011. Okay, now to work out how many moles of Al2, we're just going to say final minus initial, so delta n equals n final minus n initial. Okay, we had the final amount, they've given that to us, that was 0.016 minus 0.011. Okay, and therefore we're going to get a change in moles of 0.005 moles. Okay, now having a look at 5.5, it says calculate the maximum volume of CO2 that can be prepared at 25 degrees in experiment 1. Take mole gas volume at 25 degrees to be 24,000 centimeters cubed. Okay, so I've written everything here. Remember we have our mole ratio over here. Okay, so what we're going to do is we're going to use the mole ratio of Al2CO3 because we've got that, but we want to know how much volume of CO2 we can produce. So we have N of CO2 is equal to 3N of Al2CO3. Okay, we have the moles of this, we want to know the moles of that, so N of CO2 is just going to be 3 times Al2's moles, which is 0.016. Okay, that was given, so therefore we're going to end up with moles of 0.048 for CO2. Okay, now we know that the ratio of 1 mole of gas is 24,000 centimeters cubed as a volume. Okay, so we can use that now. So we have 0.048 moles. I'm going to start with that. Moles, okay, over 1. I'm going to multiply that now with this ratio over here. So what we want is centimeters cubed. That's going to go on top. All over 1 mole, in this case of CO2. Okay, let me just write CO2 over there and CO2 over there. So we can see that moles of CO2 and moles of CO2 are going to cancel over there. So 0.048 times 24,000 gives us a final volume, okay, of 1,152 centimeters cubed. Okay, and that's of CO2. Okay, you can use the other volume, or the other formula of N equals to V over Vm. You plug everything in and you'll get the same thing. Okay, and that's how we go about doing this question. Okay, if you found today's video helpful, then please consider subscribing to the channel. Please leave a thumbs up on the video as well if you are enjoying the videos. If you have any questions or comments regarding the video, then please leave them in the comment section down below. And I'll get back to them as soon as I can. Remember, it's never too late to have an OIC moment.